Law of conservation and chemical equations. Law of conservation of mass states that in a chemical reaction, mass can neither be created nor destroyed. Objective. At the end of this session, you will be able to explain the rationale behind balancing the chemical equations using the law of conservation. Consider that 5 magnesium and 5 sulfur atoms are kept together on one side of a balancer, and product of their reaction, that is magnesium sulfide, is kept on the other side. The balancer gains balance as the total weight of the reacting atoms and the total weight of the atoms on the product side is the same. Even the total number of atoms on the reactant side and the total number of atoms on the product side remains same as per the law of conservation. Thus, a chemical reaction does not create or destroy atoms. The atoms are only rearranged in a reaction resulting in formation of a new product having same number of atoms. To observe the law of conservation of mass in a chemical reaction, zinc granules and sulfuric acid are weighed together before reaction. Then they are mixed to react, producing a white precipitate of zinc sulfate and hydrogen gas. Weight of the products was measured. It is observed that the total weight or total mass of the reactants as well as that of the products of the reaction remains same as per the law of conservation. If the reacting atoms of zinc and sulfuric acid reaction are placed on one side of a balancer and the product atoms are placed on its other side, then the balancer gains balance and the number of atoms on both the sides are equal to. The chemical equation for the reaction also shows that each element participating in the reaction has equal number of atoms on both the sides. This is a balanced chemical equation. But in the chemical equation for the reaction of iron with water that produces Fe3O4 plus H2, the law of conservation is not followed, because the number of atoms for each element on the reactant and the product side are not the same. This equation is not balanced. It is a skeletal equation that shows only the chemical formula of the reactants and the products. This skeletal equation is required to be balanced by equalizing the number of atoms for each element on both the sides. To start with, the compound having the largest number of atoms, that is, Fe3O4 molecule from the product side, is considered. It has 3 Fe atoms on the product side. It means in the actual reaction, not 1 but 3 Fe atoms must have reacted to form Fe3O4. To get 4 oxygen atoms in Fe3O4 on the product side, not 1 but 4 water molecules must be actually present as a reactants. After losing 4 oxygen atoms, the 4 water molecules are left with 4 pairs of diatomic hydrogen on the reactant side. and they are released as hydrogen gas on the product side. Thus, the reaction releases not one but 4 pairs of hydrogen atoms on the product side. Thus, in the actual reaction, 3 Fe atoms react with 4 water molecules to produce 1 molecule of Fe3O4 but 4 pairs of hydrogen gas molecules. This gives a balanced chemical equation with equal number of atoms in their molecules on both the sides, perfectly following the law of conservation in a chemical reaction.